All right, hello everybody. The week of April 19th. Working on small engines this week. 3 weeks left. Small engines. Go over some maintenance items. Next week after that, we have our quiz, which you guys will grade each other on. Then after that, we'll have a final. So as far as equipment, this kind of brings it in to the final aspect. Kind of going over the small engine. Small engine is kind of what we operate mostly. Now with the tractor and skid steer, some of those larger pieces of equipment, obviously that's not a small engine. That's not considered a small engine. It's considered the bigger, right? That's not what this is. Small engines are on your lawnmowers and on your handheld equipment, your weed eaters, your blowers, the edger, pressure washers, things along that line, little generators, which is along the lines of what we work mostly with. So what I want you to try to get out of the small engine stuff is the familiarity with the bigger components, right? This is not a mechanics class. When you are working in the field, whether you're a technician or you're a manager, you will have mechanics that do things that fix your equipment for you, right? But to be able to change a spark plug, to be able to understand the components that kind of go into these engines, to repair a starter housing, those types of things is kind of an everyday aspect, right? You can't take care of a small engine if you don't kind of understand it, right? You can always take your car into the car dealer, let him take care of it for you. But if you don't understand what you even need to bring it in for, you're probably doing yourself a disservice, right? If you have a trusty mechanic, not a big deal. They'll tell you what needs to be done, nothing more, nothing less. But for you not to be somewhat aware of what needs to be done on a routine basis to your vehicle, you're not doing yourself a service, right? You're doing yourself a disservice. And you don't have to be a mechanic to understand that you need to rotate the tires, that you need to get the oil changed, that something's clicking, something's clacking, all of those types of things that you need to get taken care of before it becomes a problem. Same type of thing when you're operating equipment on a daily basis, right? If there's something clicking and clacking, something banging, something that needs some routine maintenance, you're going to have that piece of equipment for longer. You're going to try to get the most use out of its life. Okay, so that's kind of what we're looking at here. What I'm going to do is there's a couple videos we're going to watch. It's hard for me to kind of go through those things here, but there are some good videos out there. We'll start off with a couple as far as the actual engine. It just is the best way to illustrate what the engine does, how it operates, some of the different parts of it. We'll go through a couple pictures. I got a lot of pictures that lays out the different parts and components of the small engine. I'm not going to go into a whole lot of detail of this fits on there, blah, 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 blah. We'll do a lot of that in the lab. But just to try to, reiterate what was in the video, kind of show you the pieces, talk a little bit about this, that, and the other. And then another video on replacing a starter housing, because whatever you do in landscaping, you will either replace a spark plug or you will replace a starter housing if you want to go to work, right? I mean, eventually that string that you pull to start something, it's going to break. So you being able to replace that out in the field is vital. If it's a spark plug, to have some spark plugs on your truck, to have them available for your crews, that is ideal if those spark plugs are going bad and it's just not firing right, just not operating right. very common, um, very easy things to fix and handle in the field. Just have to kind of be familiar with it. So those are the types of things that we're going to kind of go over and get you ready for, and we will go over them in lab as well and kind of give you a better idea. But let's go ahead and start with the video. Like I say, the video is pretty good. Kind of goes through how a four-stroke engine works, the different components. It's just a really good sense of how everything kind of goes together.
The small four-stroke engine has been the backbone of Briggs & Stratton for more than 110 years. During this time, Briggs & Stratton has seen many evolutionary changes that resulted in more power and a reduction in emissions. One thing that has remained the same for all this time, the use of four strokes to allow the engine to run. Engine design and configurations. This discussion of four-stroke theory will be based on overhead valve engines. These engines have valves that are installed directly above the piston and are built into the cylinder head. This is the most efficient design that lets the engine operate and maintain longevity. First, we will discuss the two types of engines Briggs makes, single cylinder and V-twins. Then we will identify the differences between them, vertical and horizontal. Single-cylinder engines use one cylinder that supplies power. This design is sufficient for applications where moderate horsepower or torque is required. These engines range from 5.5 pounds per feet of torque to 21 horsepower. V-twin engines use two cylinders that supplies power. This design is suited for larger applications where more horsepower and torque is required. The range of V-twin engine output can range from 16 horsepower to 40 horsepower, which doubles the amount of work that can be done. Briggs & Stratton offers two engine types beyond the number of cylinders. The vertical shaft engine is the most common engine. When the engine is mounted to its application, the crankshaft is in a vertical position. Vertical shaft engines are usually on walk-behind lawnmowers, pressure washers, lawn tractors, and zero-turn mowers. The second type is called the horizontal shaft engine. When the engine is mounted to its application, the crankshaft is in a horizontal position. Horizontal shaft engines are usually on pressure washers, lawn tractors, zero-turn mowers, lawn splitters, and construction equipment. Operation fundamentals. Three conditions are necessary to make an engine operate. The first condition is a sufficient air and fuel supply. You can group this into one element. The second condition is an ignition source. A spark occurs at the spark plug gap. The third condition is compression. In order to have a sufficient energy released when the fuel and air is ignited, the mixture must be compressed. Without these three necessary conditions, the engine will not operate. Four-stroke theory. In a four-stroke engine, 2 full revolutions of the crankshaft are necessary to complete the 4 strokes. Four-stroke sequence is as follows: intake, compression, power, exhaust. The camshaft is a crucial component used to make 2 of the 4 strokes occur at the correct time. The camshaft is paired to the crankshaft with a gear set so that it correctly maintains the timing of the intake and exhaust valve events. The teardrop-shaped lobes on the camshaft also control how far the valves open and the amount of time they remain open. The camshaft turns at half the speed of the engine. For example, as the crankshaft completes a full revolution, The camshaft has completed 1/2 revolution, or 180 degrees. The camshaft will complete 1 full revolution when the crankshaft has completed the necessary 2 full revolutions to make all 4 strokes. The main role of the camshaft is to open and close the intake and exhaust valves. The flywheel on a 4-stroke engine is used as a source of rotational energy. The inertia keeps the engine turning. This is important because the engine only makes power to turn the crankshaft during one of the strokes. The flywheel makes sure that the engine continues to turn with sufficient speed to smoothly complete the 3 remaining strokes. The flywheel contains a magnet that makes electricity through induction. The ignition armature will cause a spark at the spark plug. The flywheel must be timed correctly to the crankshaft with a flywheel key. The ignition source for the power stroke will then occur at the correct time for accurate engine operation. Intake. When the engine turns and increases rotational speed, the piston moves inside the cylinder bore as the engine goes into the intake stroke. The camshaft opens the intake valve. During the intake stroke, the piston quickly falls inside the cylinder bore. This fast movement causes low pressure, or a vacuum, in the cylinder. The low pressure signals higher pressure outside the engine to equalize it. The outside higher pressure air moves through the air filter and carburetor. The fast airflow through the carburetor venturi gives another pressure change. The change in pressure lets fuel be cooled from the bowl to the carburetor directly into the incoming airflow. This air and fuel mixture will move into the combustion chamber before the piston is at the bottom of the cylinder. The camshaft will also close the intake valve. Keep in mind that some fuel can adhere to the intake runner. This wall wetting can cause inconsistent fuel delivery. This is common with carburetors and is compensated for. The intake stroke has been completed. Compression. With the 2 valves closed, the piston moves up to compress the mixture. As the mixture compresses, it makes heat, and the liquid drops of fuel turn into vapor, which will burn easily. The mixture is compressed approximately 8.5 times its original size by the time the piston is at the top of the cylinder. This compression process makes a more explosive mixture. When ignited, it gives sufficient force to push the piston down and turn the crankshaft. The compression stroke has been completed. Power. As the piston nears the top of its travel during the compression stroke, with the 2 valves remaining closed, the mixture is at its optimum point for ignition. Immediately before the piston is at the top of its travel, the magnet on the flywheel moves past the ignition armature. This magnet makes a small amount of electricity, which is amplified in the ignition armature to approximately 12,000 volts. This voltage moves instantly through the spark plug wire to the spark plug. The movement of electricity across the open air gap of the spark plug to the ground strap causes a single spark that ignites the mixture. As the mixture burns, it moves across the top of the piston. This causes a pressure wave, which pushes the piston and connecting rod and turns the crankshaft with force. The pressure wave will act on the piston for most of its travel toward the bottom of the cylinder. The power stroke has been completed. Exhaust. When the piston is at the bottom of its travel, the camshaft opens the exhaust valve. The piston will begin to travel back up the cylinder, pushing out all of the remaining spent gases. This is important because these gases will not support combustion again and need to be fully removed from the cylinder. When the piston is at the top of its stroke, the camshaft opens the intake valve and the exhaust valve. This design feature is called valve overlap. Overlap uses the exhaust gases leaving the exhaust system to create a vacuum in the combustion chamber to help initiate the intake stroke ahead of the piston starting to travel back down the cylinder. This feature is part of the camshaft design and has no physical adjustment. The exhaust stroke has been completed. From this point forward, the engine will continue to operate and complete thousands of four-stroke cycles until the engine stops after you remove the ignition source or the fuel source.
Okay, so did you get all that? Don't worry if you didn't. I'm just going to, it's a great video to reference that combines everything together, obviously. You know, for you to be a landscaper in the horticultural business, whatever the case is, for you to be knowledgeable on all that type of stuff, you know, you're looking at more mechanic type things. That's depending upon your role, it's fine, right? But at the end of the day, to understand how those things work, to know that there's multiple different components that are going to affect how that piece of equipment operates, you know, is going to separate you from the next person, okay? In addition, it's going to also allow that piece of equipment to get its most life, okay? So another little video, and then we'll kind of reference and kind of go into a couple things.
You see two-stroke engines constantly. They power weed whackers and chainsaws, model airplanes and boats, and all sorts of other stuff. The reason why they're so popular is because they have an incredible feature. For the power they produce, they are incredibly light. The key to the two-stroke design is a piston that acts like a piston, a compressor, and an intake and an exhaust valve. If you watch a two-stroke engine go through its two strokes, you can see exactly what's happening. Let's start with the spark plug fire. At this point, the piston is at the top of its stroke. The cylinder is full of air and gasoline that has been compressed. When the spark plug fires, it lights the gasoline. The gasoline bursts into flame and expands rapidly, driving the piston down with a lot of force. See this area behind the piston? It's filled with air and a mixture of gasoline and oil. As the piston moves back into this area, it compresses the mixture. As the piston gets near the bottom of its stroke, it uncovers a port. That port lets the exhaust gases escape into the exhaust pipe. Then, just a fraction of a second later, the piston uncovers another port. That port lets a new charge of air and gasoline into the cylinder. Now the piston starts moving back toward the spark plug, compressing the air and gasoline mixture so the spark plug can fire again. This cycle repeats thousands of times per minute. You can see that the piston is doing three things besides being a piston. It's an intake valve, an exhaust valve, and a compressor. Because the piston is doing so many different things, it makes the engine incredibly light. You can also see that the spark plug fires once for every rotation of the crankshaft. That's twice as often as the spark plug fires in a four-stroke engine. So not only is a two-stroke engine intrinsically lighter than a four-stroke, but it also has twice the power. The other advantage of a two-stroke engine is that it can work in any orientation. As long as fuel is flowing to the car, this engine is completely happy to work right side up or upside down. So that's how a two-stroke engine works. I'm Marshall Brain, and that's how it's done.
Okay, so when we're talking about our business, right, we got four-stroke, two-stroke, four-stroke engines, most of your lawnmower stuff, most of your pressure washers, generators, those types of things, okay? Your handheld is two strokes, okay? Both are small engines, both are considered in that small engine, but they are two different types of things. Two-stroke, main differential separation is your oil and your gas is one, okay? A four-stroke, you have gas. You put gas in the gas tank, and you have oil that is in the block, right? That's in the engine itself. So it's two separate. In the two-stroke aspect, that oil and gas is mixed. It works together. Okay. So four-stroke engine, you have four components. Okay. Not going to get too caught up on this type of stuff on that aspect. Just try to show you a couple things while we're fresh in the mind. Okay. So four-stroke cycle, right? You had four components: the intake, the compression, the power, the exhaust. So once it completes that cycle, that's one stroke. Okay. So I'm going to skip through a couple things and work our way back. I think we did talk about the crankshaft, right? That crankshaft can be horizontal or vertical, depending upon the engine and the makeup of that engine, right? How it fits in the piece of equipment that it's on. Okay. So the piston. Okay. So we're talking about the piston because the piston is very important on both pieces of equipment, right? Here's your piston. Okay. There's rings that go around the piston. Okay. So when you talk about the pistons, if an engine isn't working right, it can have a lot to do with this piston, because this piston is under a lot of stress, and so are these rings, right? These rings are moving in and out, and it acts as a seal. So if this loses its integrity of what it's supposed to do, right, it's going to let more air in, which is going to cause that engine not to work properly. So there's just a couple, there's some interesting factors, of small factors that can affect, how your piston works, right? Whether it's the compression ring, you got a wiper ring, you got an oil ring, all these different rings that are here that are going to affect how much compression, how it holds that, holds everything in place, all that type of thing. When we talk about pistons, this is your piston that has these rings on it. That there's not a lot of room for error when those things go wrong, right? But think about what that piston did, right? Think about what that piston was, kind of the stress that piston is under. These rings can easily get damaged, causing you problems on that engine. Okay. So another piston, how it kind of all fits together. Just trying to show you, that aspect of what it looks like. Here's your valves, right? These are the ends of the valves. What comes with the valves? You have your springs on your valves, right? Okay, so if a valve isn't working properly, it's letting in too much, letting in too much fuel, letting in all that too much. It's not working properly. That ring could be worn out, right? So you have to take that apart and get that ring replace this valve. There's a couple different components of what all can go wrong, right? So they're just trying to show you those aspects of the video that we just did watched. Okay. Okay, kind of going back to the front. Okay, so this is our crankcase. This is what houses everything, your cylinder block. Okay, you got a crankcase cover over here, right? So this kind of all goes together. Where your spark plug comes in. See a little bit of oil down here. This is what holds the oil. Okay. The camshaft comes in here as well. That's where your camshaft is going to sit. Okay. So that was the engine block. That's what it does. you have your head gasket here, your valves coming in here. This head gasket here, if this is leaking, gets a crack in it, the seal just goes bad. All those types of things, you know, this is going to leak. You have to take the whole engine apart, replace that one little gasket. You know, that's something. Obviously, it's letting in air. It's not running properly. It's not having its optimal performance. All those things are components of this engine that happen, right? So there's your spark plug. Your spark plug sits in here. Okay. Crankshaft, talk about that. Can be horizontal, can be vertical. Here's the gear that they were talking about. It has that timing gear connected to the flywheel, right? You know, it's weighted. Okay, it's weighted for the timing aspect. Okay, so that balances the weight. Okay, kind of going through the piston, going back through the piston. Say going back and forth, trying to relate it to what we're talking about. Okay, here's your camshaft. This gear goes back onto your crankshaft, right? So that gear matches up to this crankshaft gear, okay? And that's what's going to hold everything together, or spin everything. That's where the timing comes in. So if you were in the mechanic world, right, when you're putting an engine together and you're taking an engine apart, those types of things, you can't just line it up where you think you're going to line it up. There is a science, lack of proper terminology, there's a mechanic science to the timing of that engine, okay? There's tools, and there's a specific way that you have to do that. It's not just matching those pieces up and it magically works right. No, it has to time itself properly, kind of like it said in the video, right? It has to hit that same mark as far as the timing. Okay, so that's kind of where I say, you know, what do we want to understand? We want to understand that that's how that operates, right? We understand that there's a camshaft connected to another gear, and that timing has to be worked, right? You know, to know how to put that timing together, to have the tools and the equipment to do that, that's another level, okay? That's another level of mechanicking, if you will, on how to do that, okay? You wouldn't do that as an operator, as a manager, because that stuff takes time. It's a different skill set as well, you know, in order to do that. But to be able to understand that these things are all components, that they all work together, you know, it's vital to what we do. Going back, here's your valves again, right? Those valves sit in. Once again, those valves under a lot of stress too. If they're working, those springs under a lot of stress, not much to it, you know, springs easily get worn out. That's where when you look at the equipment that we operate, you know, especially some of the two-stroke, some of the handheld things, right? When you pull that trigger, that thing's wide open. I mean, it is 0 to 100 in however long. You know, it is wide open, and it is running at its wide open capacity. So you think of a race car. You know, what else runs wide open all the time? With your vehicle, it's not wide open. You're 45, 55, 65, 70 miles an hour down the road. If you just floored it everywhere you went, you know, how long is that engine going to last, right? Just like a race car. How long does a race car engine last? I mean, they're going around the track, you know, 100 plus, 100, depending on the track, right? 150, 170, 180 miles an hour going around a track. I mean, they are throttled down, you know, on that engine. I mean, that thing is cranking. And you know, all these components are under that much stress when you're doing that. So when you think of a two-stroke engine, when we're pulling that trigger and we are wide open, chainsaws, all that type of stuff, you know, this isn't a, you know, $1 million piece that's going to last forever, right? I mean, this is a simple little piece, you know, that can break, right? I mean, go back to a piston, right? I mean, you know, these seals on this small little piston, right? That's 2 inches, you know, 2 inches in circumference, you know, or diameter, I should say. You know, there's not a whole lot to it, right? So that thing is wide open, throttle down the whole time. You know, it's under a lot of stress, these pieces of equipment. And that in these components of this engine, right? So understanding that and understand what these things look like and how they operate. Flywheel, okay. Here's a magnetico, right? So this is putting that magnetic spark into the spark plug, right? As it rotates around on the flywheel, as the flywheel rotates around and it's hitting that, right? So that's a timing mechanism too, right? This I had in here. There's just a couple of different things, right? You're going to have an air filter on your equipment. You know, that's another component that is easily maintained on a routine basis, whether it's, you know, whether it's on a lawnmower when you're mowing and it gets dusty. I mean, obviously it's sucking in that dust. Those things need to be cleaned out. Your weed eaters and your blowers have air filters on them as well. Same thing, right? Your weed eating, that thing's sucking up dust all around the weed eater, the blower. Obviously, I mean, you're blowing dust, it's sucking up dust, it's doing all that stuff. You know, your air filters are important to keep them clean. That's what allows your engine to breathe. You know, to cool itself, you know, all that type of stuff. You know, you get your air filter too hot, you know, that engine is not cooling, it's not breathing the way that it should be. It is operating at a higher temperature. Go back, I'm not going to keep flipping back, but go back to that piston, go back to the rings around that piston, go back to the valves, right? They're not, like I say, they're not $1 million pieces, they're simple pieces. That puts a lot of pressure, a lot of stress on those pieces. They're just not designed to withstand that kind of pressure, that kind of stress for a lifetime. You know, they have a shelf life, they have a useful life, right? But it's a $400 piece of equipment on average. It's not going to last forever. But these are the things that we can do to prolong that life. Here's a carburetor, you know, that allows that proper mixture of that air and the fuel in there. You know, this is what regulates that. These can go bad as well. It's your intake manifold, muffler guard, dipstick you'll have on when you're checking the oil on your 4-strokes and your starter housings. So going into we'll go into another video, starter housing, being able to change the spark plug. Your spark plug is going to sit in here on some of those, on some pieces of equipment. It'll sit in on your engine on some of the others, right? So this will put on the top of the spark plug. Then it goes back into your back in here, right? So you have to take that spark plug out, a wrench, unhook it from the other end, unscrew it, it from this magnetico, this piece of the hose, right? And then swap out that spark plug. So your spark plug, your air filters, those things are easily maintained out in the field. Okay, the starter housing, you know, that's your pull cord, right? That's your pull cord that you're going to start some lawnmowers with. You know, obviously a lot of your two-stroke stuff will have a pull cord. You know, there are some four-strokes that will have a pull cord as well. You know, all it is a piece of rope in here, right? So that thing can get frayed. You can eat your Wheaties one morning and pull that out, right? You can pull it straight out, break it, whatever the case is. But this is how your piece of equipment starts, right? So you have to pull that in order to get your piece of equipment to start. You know, it's important that you have this. So it's important that you know how to fix this, because this is something that happens in the field all the time. Okay, so we'll do a lot of this in the lab too, but to try to give you a rundown of a quick common thing, as he's saying. Sorry.
We get this call here, a lot of their tools. I don't know, replace my starter rope. People think they have to buy.
And he'll say it here in a minute, but it doesn't matter. This is a Honda, comes off a Honda engine. They're all the same, right? I mean, there's some different nuances of each one, but the general gist is the same, right? Number one, you're pulling it, so it's on it has a pulley in there, right? And it's winding it back up. So at the end of the day, they're all similar. It doesn't matter if it's Honda or the next brand or whatever the case is. There might be a slight nuance of one to the next, but they are very similar in the mechanism of what it is. And he'll go through that too.
This is a brand new recoil starter off the Honda engine. This rope got a little cut here during the project, so I'm just going to replace this to go. So I'm going to give you a little walkthrough on how to replace this thing without having parts flying all over the place. So first thing is to take this off the engine. As I mentioned, this is off the Honda engine. On the BCS machines, getting the recoil starter off usually entails having to take the engine bumper off. Some models you can buy without taking the bumper off. It just depends on whether you can access the grease screws to start on. Sometimes there's also a debris screen over the recoil starter. That would be like a black perforated metal screen that we install on there to keep trash from getting sucked up into cooling pins. If that's in place, you take out the built-in screw, hold it on, pull it off, and access the whole recoil starter on. This procedure that I'm going to show you here is good for just about all small engines. You can certainly get to the Honda. It could be the same on most Risen, Stratton, Yamaha, Kohler engines. Kohler diesels are a little different because you have to take the rope pulley out of those. Most of these other ones have a knot on the pulley to access pretty easily the top of the pulley, so you don't actually have to pull it. So what I'm going to do, I'm going to pull this completely out until it's at its fully extended point. Now, Honda makes it real easy because they have this webbing in the center of the pulley here, which makes the pulley kind of a pass-through. And they also have these slots in the recoil cover. Actually, let me select a slightly smaller screwdriver. Do this one here. And stick all the way down through there. Now, it's jammed in place. The recoil can't rewind. It's trying to rewind. That is, if this wasn't here, the spring would just wind it back up. I don't want it to do that. I want to pull this all the way out so the spring is fully charged, fully loaded. And now, and I'm not going to want to set that down on the table and let that thing push the screwdriver back up, or else it will just pop back in. So now I'm going to take this out. Now, if your rope is already broken, completely broken in half while you were pulling it, then you wouldn't have to particularly, you won't have to remove the old rope. But what you would do in the case, actually, well, I'll simulate that here in a minute. Shut up, this ain't working. So now I'm going to cut this knot out. this out. So rope is out. Now, if your rope had broken, as I was just starting to say, then of course this spring would be completely discharged, as this thing would have boinged and just would be doing nothing in here. So there'd be no spring load to start with. In that case, you can spring load this before you install the new rope. The easy way to do that is simply look at the recoil starter housing, figure out which way the rope would have wound in there. You can always tell by the angle at which this eyelet is in here. So I can see that this eyelet sort of facing up. So I know the rope winds around this way. So you turn the pulley the opposite direction. Oh, I'm sorry, no. Turn it the same direction, right? Because that's what you're on. So as you pull this, it would be tensioning the spring. So the imaginary rope would be tensioned this way. So I'm going to pre-tension this spring by wrapping this thing up. And I'm going to wind it and wind it and wind it gently until it stops. Now that's the stopping point right there. Now that's when it stops is when that spring, there's a big spring in here, that spring is now completely wound up tight. I don't really want that spring to be what stops the rope when you pull out the rope to the fullest point. If it is, you'll break the end off the spring because the spring will be, under a lot of stress every time. So now that I've fully charged it, I'm going to let this pulley back, and I'm going to look for the little hole through the pulley where the rope would line up with this eyelet where the rope comes out. So there's the point right there. There's the hole. And there's the eyelet that it passes out. So I've wound up the spring fully, and then I backed it off to the point, the first point where that hole lines up with this hole. Then I'm going to lock it in place. Now the spring is going to have enough tension to pull all the rope back into the thing. That's the cheater trick to rewinding the spring, or recharging the spring. These handles are fully reusable. You usually just have some kind of a plastic insert in the rubber there. You don't need a new handle because you need a new rope. Pull this stuff out of here. Now, I'll do that. Here's a new roll of rope. Rope is just sold by the foot typically. Anybody who sells it in cut lengths is just cutting it off in a big roll and charging you more for it probably. So I'm going to match this up. It should be about 5 feet. This one's probably a little shorter than that. You can fit a little long of this thing. About 6 inches longer than the original here. The tie knots space. So I'm going to use a propane torch. You can use a match or a big lighter or something. I like to burn the end of this rope just a little bit, just to keep it from unraveling. That's real good for calluses. If you don't have calluses, you know what to do. So now I'll feed this in through here, get it fed through the pulley. It takes a little finesse. I was real lucky. I hit the hole in the pulley the first time. Sometimes you got to kind of get down in there with all those pliers and pull it through here. Somebody's paging me, they're going to have to wait. So I'm tying a knot in the end of the rope. Just a single square knot is usually sufficient. Well, this one has a lot of room for a knot in here, so I'm going to actually give it the double loop square knot. Absolutely ensure that everything loose. There we go. All right. And that's going to confirm. I'll pass this up here. Do the rubber first, and then through the insert. Plenty of room in that handle for double as well. So one loop through, two loops through. Wow. Nice and snake. Here. All right, perfect. Now, this out, I'm going to hold the pulley with my thumb just so we don't have out of control release here. And voila, right back in. And work just like it should. Now, there are some cases you find where, you have a recoil starter where we call it its tongue's hanging out. And that's a case where, like you've used the thing a long time and maybe the recoil spring possibly at some point just put a rope in it and not tension the spring properly. I'm artificially tensioning the spring here. So there it is. It's an engine with its tongue hanging out. I'm really tired. So you can fix this without taking this whole thing apart. You can do it just in the reverse of how I just did it. So I'll walk through that a little slower. So what I'm going to do to tighten this, I need to tension that spring without winding up more rope on the pulley. So what I'm going to do, I'll pull it out, maybe a foot here, just to expose some rope. Slip this rope out from behind the pulley. And some engines have a little notch in the side of the pulley. It's like just a little U-shaped knot. And how many engines don't bother putting that in there? But actually, some older models, you can still find that. A lot of the bridge motor, older motors, most engines have some kind of little notch on the recoil pulley. And that's handy because when you pull the rope out like this to tension the spring, you just fit it up into that notch. Since this doesn't have a notch, I just have to sort of hold that spring or the rope with my thumb against the pulley, and I use the rope to actually tension the spring. That is, I'm winding this thing up, and I can feel that I'm tightening the spring. So I'm tightening the spring. I just did one round without wrapping the rope on anymore because the rope was disengaged out of the pulley slot. So that was one. Now, I know that this feels a little weak. It's not great. I've taken 2 loops off this earlier. You saw me do it, so I'm going to put 2 loops back on it. I could have done 2 at once. So now it snaps back nice. Now, you can over-tension these things, of course. If it's over-tensioned, then it would be a case where when you pull it out to the maximum point, if it stops, if the pulley stops before this is lined up, you know it's actually bottoming out of the spring. And that's over-tension. You're going to break the spring if you keep running it that way. So back it off 1 loop so that at the end of the rope, what's stopping you is actually the rope and not the spring pressing. That's it. Little lubricants around the moving parts usually help. If you've got a kind of rewind starter with these kind of little jaws that jump out of it here, it's not a good idea. Those are the jaws that engage with the flywheel of the engine to start them.
So something that will happen in the field, I don't want to say daily, but often, you know, you will love to have to be able to reference this, be able to do these things automatically. This is something that we will practice in the lab. This is something that we will do in the lab. We'll go over it again in the lab. It's not difficult, number one. You know, he obviously makes it look easy when he's going through it with the video. You know, somebody that knows how to do it will make it look easy. But when you do it a few times, it becomes easy. Not that complicated. Just a spring, recoil, just getting it lined up right, getting a good knot in there, getting your proper length of your rope. So you know, kind of the important things. But as far as a small engine fix in the field, need to learn how to do that. Very vital skill to learn how to do. So this is something we will do in the lab and see if we can perfect it. So small engines, kind of going back and forth a little bit. We'll go through the lab. Good PowerPoint to have reference to look at different things, to look at different components of that small engine. But as you go along in your career, as you move forward, I want you to think of, I want you to know of the small engine. I want you to know of the components. I want you to know how they kind of go together. You know, but at the end of the day, to become a mechanic, there's different skill set, right? There's the timing mechanisms that need to be known, that need to be put together if you're going to rebuild and replace some of those pieces, right? So that's not field work, that's mechanic work. But to be able to understand that, to be understandable how you need to take care of the piece of equipment because of the pressure and the stress that it's under, you know, it is very important. And that knowledge and what you to carry out of this class into the field, you know, as management, will be appreciated and help save companies money and that type of thing. So our motivation thing that we have, I won't click on it. We're pushing the time today. It's short. It's not very long. This one is about speaking, you know, in teaching, right? You know, how do you create the magic when you're teaching? How do you hold the audience's attention? How do you do that? You know, he has very good background and very good ideas and thoughts on how that works. Like I say, short video, not long. I think it's 6 minutes. Please click on it. Please look at it. It's trying to just help you focus on keeping an audience attention without going over the top, right? We don't have to stand on our head to have people pay attention, but what are the things that helps them pay attention, right? So please take a look at that. Our discussion question for the week, you know, what it's kind of a feedback aspect too. You know, what's been the favorite piece of equipment, you know, that you've experienced this year? Why? And what's been your least favorite, and why? You know, I think it's good to kind of talk about it, see what everybody else enjoys, see what everybody else is not enjoying. Kind of helps me as well, kind of moving forward in the program. Maybe we eliminate some things, maybe we need to add some things, whatever the case is. So that's our discussion question. Once again, this is almost the end of class. Next week we have our maintenance aspect. We'll kind of go over some greasing, some cleaning, benefits of doing that to your equipment, how it affects the equipment and the operation of that equipment. And then the final 2 weeks will be quiz and test. So almost there, folks. Let's try to finish it strong and see if we can't end it off on a good note. I will see you guys in lab on Monday.